According to synthetic astronomy and other resources, people looking at the sun and gauging its size and distance using a sextant, apparently the sun would be just shy of about 40 miles across and roughly 3,000 miles high. So obviously that's not being depicted here. That scale's not accurate, and it would go in and out on the various tropics and of course the equator. For more information on that, see my animation to the right there. It says how the 4 seasons work on the flat earth model. Check that one out, and also you might want to listen to the radio show that I did with Zen Garcia, who's done some amazing work in tying all this into the Book of Enoch and how Enoch describes the various motions of the heavenly luminaries. Lots of good stuff there. But of course, the critics look at this and they say stuff like,
if the sun and moon were just circling over the flat earth and getting too far away to see, then we would see them shrink and fade out of view as they set. But we don't. Flat earthers will show you videos where the sun appears to grow or shrink, but this is an illusion due to thick clouds. You can always see that there are clouds near the horizon when they try to show this. Normally, this illusion does not happen.
Oh, so he said that flat earthers are always hiding it behind clouds or whatever. Well, there's plenty of footage out there you can find where there's no clouds involved. This is from a really good video online you guys need to check out called Flat Earth Proof Sunset Off Pucket. I'm not sure if that's exactly how you pronounce it. P-H-U-K-E-T. Really interesting, showing sunset. I believe this was actually somewhere off the equator. Again, you'd have to watch that video for yourself, but it clearly shows the sun changing in diameter as it goes away. So please take note not to ignore this evidence. Other videos you've seen where it looks like it's going in an arc like that and going off into the distance. Other videos where people have taken and used filters and whatnot and analyzed the sun moving and then done measurement of pixels across the screen, showing that it does in fact look like it gets a little bit smaller in some cases it gets a lot smaller. In this case from 302 pixels to 290. And then of course there's this video right here, which apparently was shot in the desert, where there's going to be a lot less moisture, and so whenever there's less moisture you're going to obviously have less refraction and magnification.
You don't get to pick the anomalies that seem to agree with your views and ignore the common observations that don't, and still call yourself an honest investigator. That is intellectually dishonest.
So thinking about all this and thinking about what I had just shown you regarding atmospheric lensing, magnification, refraction, all that with regard to cities and objects at a distance on the land, I got to thinking, I wonder how this would work with the sun and moon. So this is what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. Alright, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification it does what we might expect it would. It gets smaller as it goes away from us. Alright, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size too. Pretty close. And of course that's because as it's moving away, the magnification is still taking place, and so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Of course, again, depending on how much moisture is in the air, we could see that the sun doesn't appear to change in size at all as it goes down. We could see sometimes perhaps that it looks like it's getting bigger when it goes down. You ever see like a really big sunset or moonrise, moonset, you know, where one of them looks really large on the horizon? Well, that could be because there's lots of moisture in the air causing that effect. Or when there's less moisture in the air, obviously you won't have as much magnification taking place, and so it looks smaller as it goes away. So it's all relative to the amount of moisture that's in the air. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob SKIBA could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about. If you've been following some of my other videos, I've been showing how I believe the sun and moon work over the flat Earth model, and taking advantage of the fact that the atmosphere is full of moisture and that it is acting like a lens. I've done a number of videos, and one of the questions that has come up a number of times actually is, how is it that the clouds can be lit from underneath? Now, in the spinning heliocentric globe model, it's essentially explained that as the Earth is rolling away from the sun, as it's, you know, spinning, it rolls such that the sun is at a much lower angle, and because of that angle, the sun is shining up, and the sun rays are hitting the bottom of the clouds. So when you show people the model of the sun going around in a parallel path above the circle of the Earth, they say, well, you know, in that situation, the sun is above the clouds, and so how could it possibly illuminate the bottom of the clouds when it's doing that? So I decided to take up that challenge and see if I could figure that out based on what I had learned in my previous experiments. And so I got one of these stick-em-up LED lights. You know, you kind of push the button, it's got 3 little LED lights inside. And I taped it up so only one of the LED lights is showing, and stuck it on a box and put it on the table with my trusty plastic lens set up here. And I took my stand that I was using for the sun and moon and just set it up right here on top of these little Tupperware things. And I was thinking, okay, so that's, let's just say the bottom of this little stand here represents the bottom of the clouds. And so as you can see here, the light is way above, you know, it's well above what would be the bottom of the clouds in this example. So let's see what happens. I turned off the lights and set my iPhone to record, and I'm showing myself here recording all of this with another camera, and I pulled the light back on the table, and watch what happens here. Ooh, check it out. There's that refraction taking place again. It's got the light. It made the sun set, first of all, below the horizon in this case. And let's just show, this is just the iPhone view. I'm going to bring the cloud in here, and the platform represents the bottom of the clouds. So the sun's going down, and whoop, there it is. The bottom of the clouds illuminated by a light source that's well above the clouds, moving parallel over a flat surface. So apparently it's possible for the sun to illuminate the bottom of the clouds even on the flat Earth model. Now I'll let you think this through with me. Okay, let's just imagine our world as a beach ball. Alright, the lines of the ball clearly point out what so many in the ball Earth camp are blatantly ignoring. A ball, by its very nature, demands that its surface immediately begins to curve downward and away from any point on it. So if we imagine Poser James here, I'm using a software called Poser, let's call him PJ for short. If we imagine him standing on the beach ball, the problem becomes immediately apparent. Okay, he's standing on a ball. Immediately the ball is curving downward and away from his feet in all directions. That's what a ball does. And it doesn't matter how big the person is, nor does it matter how big the ball is. But let's go ahead and shrink PJ and enlarge the ball for the sake of example here. Now, notice the lines are still curving downward and away in all directions, even though he's getting smaller and the ball is getting bigger. This never changes with scale. Okay, now let's zoom into tiny PJ on the massive ball here and consider the curvature word problem that was brought up by this individual serving in Iraq. If PJ was 6 feet tall and he had a clone, who was also 6 feet tall, right, who walked 1 mile away from him, the ground his clone would be standing on would be 8 inches lower than the ground that he was standing on, right? Again, the curvature math is 8 inches per mile squared. So the first mile, 1 times 1 is 1 times 8 is 8 inches. So the ground from point A to point B is going to be 8 inches below point A. All right, you with me so far? Now, if the clone had a clone who walked another mile away, that clone's ground would be 32 inches below PJ's ground. Why? Because it's 8 inches per mile squared. 2 miles, okay, 2 times 2 is 4 times 8 is 32. So the ground that clone number 2 is standing on is 32, almost 3 feet below the ground that PJ is standing on. And if we had yet another clone who was to walk 1 more mile, his ground would be 72 inches or 6 feet below PJ's. Thus, the top of clone number 3's head would be even with the bottom of PJ's feet. I know for some of you the gerbil just jumped off the wheel, so let's look at it again. This time we'll check it out from a different angle. Again, PJ's clone walks 1 mile away. The top of his head would be 8 inches lower than PJ's. Another clone walks an additional mile, and the top of his head is then 32 inches below PJ's. The third clone walks 1 more mile, and at just 3 miles away from PJ, the ground clone number 3 is standing on is 6 feet below PJ's. Thus, the top of clone number 3's head is going to be even with the bottom of PJ's feet. Now, I'm not trying to see whether or not the person can see the other person. What I'm trying to show you is the issue of the ground level. The ground level is the issue that I'm focused on with this example. Because if clone number 3's ground is 72 inches below the ground that PJ is standing on, it's going to be physically impossible for PJ to look straight ahead or to the left or the right or behind him and ever expect to see the horizon at his eye level. It cannot be done. I'm going to say it again. If you're just looking straight ahead, there is no way the horizon could ever be at your eye level. When the ground you're standing on is immediately beginning to recede away from you in every direction, you're standing on a point on a ball, supposedly. The ground you're standing on immediately begins to recede away in every direction 8 inches per mile squared. Now, I understand we're not on a perfect beach ball, but you actually compound the problem if you start using the argument, well, there are, peaks and valleys and hills and mountains and plateaus and canyons and blah, blah, blah. All you're doing is pushing the problem further out, and eventually you, the ball earther who uses this argument, are the one who's in danger of falling off the edge of something, because you can extend that out only so far, and then you're going to have to correct the terrain back to that 8 inches per mile squared so that you can have your 25,000 mile circumference ball. Or pair if you choose to go by Neil deGrasse Tyson. But for this math to be true, and it has to be in order to maintain a 25,000 mile circumference. Okay, to be fair, I do understand what Captain Fingernail Polish is saying here. This is a typical argument that I've heard lots of times, actually. Ball earthers will claim that just like the blue circle at the top of the beach ball here, that's the visible horizon. So from whatever point you're standing on, and you're looking out toward the horizon, in 360 degrees, that line is going to be the same. It's always going to be right there. But as I'm showing you, that only works if you're looking down. I don't care how big the ball is. I don't care how big you are. I don't care how small you are compared to the ball. If you're standing on the ball, the point at which you are standing, from that point outward, is receding downward at an exponential rate. Downward. Which means you can never look out to this mystical circle out in front of you at eye level. It cannot be. It can't happen. So this whole idea right here, while in principle it sounds good, looks good, but it's a myth. It does not exist in the observable, testable, and repeatable example of reality. According to Pythagorean math, the 25,000-mile circumference ball Eratosthenes invented does not allow for us to ever be able to see the supposed edge of a horizon that presents itself at eye level. Yet whether we're on the ground or flying up to 37,000 feet in an airplane or sending up a weather balloon to over 100,000 feet, there's that totally flat horizon straight ahead at our eye level. Always. That's simply not possible if it's receding downward and away from us at a rate of 8 inches per mile squared, which is what it must do. But once again, in reality, we don't see this. Therefore, this whole idea that's depicted here and that was depicted with the slicing of the orange, that whole idea is a myth. It doesn't exist in reality unless you're looking downward, which I don't know about you, but I don't go around in my everyday life looking at the ground. I stand straight up and I look straight out, and there's the horizon at my eye level. Not possible with Pythagorean math on Eratosthenes' ball. And speaking of myths, people who think ships are disappearing over the curve in less than 10 miles distance, it's got to work both ways. I mean, if we're on a ball, then when the ship is going away from you on the, let's say, the z-axis, going, you know, from you to a point away from you, and it's rolling over the ball in less than 10 miles, then you should have the exact same effect looking left to right on the x-axis. You should be seeing ships rolling up to the top of the ball and rolling down on the lateral x-axis. You know, I mean, if it's a ball, they got to be rolling both ways, away from you and side to side. We never see that though. You can go to the beach and do a panoramic shot and put a parallel line over it, and from end to end, and this is a lot more than just 5 miles, there's no perceived curvature here. None. Flat as a pancake. In fact, these are some pictures I took on the beach at Malibu, California. And I went from there way up into the mountains above Pepperdine University and looked out. And I mean, easily there's got to be probably close to 100 miles left to right. The distance on the horizon there, it's got to be, you know, quite a bit there. Put a parallel line over it, flat. So you can't have it both ways. You can't say ships are rolling over the ball on the z-axis without having the same exact perception on the x-axis.
Calculate the distance to the horizon for any viewing height, and it also tells you how much of an object will be hidden behind the horizon if it's past the horizon. The site is metabunk.org/curve.
So I went there, and this is the calculator that's there, and you can run all the same calculations that I showed you in the other websites. You know, it works very much the same way. But this is what's interesting to me. Let's look at this graphic right here on the bottom. See, they always got this thing in the middle between the observer and the target, and it's called the bulge. And they'll have you believe that everything you're looking at is on the other side of a big hump, a big bulge. You're always going to have to walk uphill first and then walk downhill to get to wherever you're going. In all of these examples, it's always this way. Okay, they got this target, you know, over here, and the observer over here, and this big bulge in the middle. And that's what all these ballers would have you believe, is that everything you're looking at is on the other side of a big bulge you're going to have to walk or drive or swim or take a boat or fly over to get to. And somebody else has done videos on how big that bulge would be if you're flying from like Los Angeles to Hawaii. I mean, it gets quite absurd when you start putting it into these terms. But let me just simplify all of this for you and bring PJ back into the picture. Now, he's standing on top of the ball, right? But I'm going to slide him over to the observation point here. Now, I'm keeping him perpendicular to the ground. Now, do you see the problem? The only way he could be looking toward the top of the bulge is if he's tilting his head down. He'd have to be looking down. He couldn't be standing straight up, looking straight out. The only way he's going to see the curve is if he's looking down. Let's keep PJ looking straight ahead, and I'm going to slide him down so that his eyeball essentially ends up on the ground, looking straight out, and you're going to see the problem here. Look, at ground level, if his eyeball is on the ground and he's looking straight out, the ground is beginning to immediately curve downward. There's no bulge. There's no bulge. Balls, it don't work that way. If you're standing perpendicular on top of it, and then you point on the ball. But yet every single curvature chart you're going to find is going to show this same kind of nonsense, where they either have the observer or the target at ridiculous angles, or they're forcing the observer to look downward, such as in this example. But there's also plenty of others that depict essentially the same thing. In fact, if you go back to the Channel 57 ABC news report, Skyline Skepticism, the Lake Michigan Mirage, you remember the weatherman said,
now we have a lot of web extras with this story. Log on to abc57.com after this newscast. You can see the time lapse, a short lecture by Dr. Rennie, and how you can calculate how far you can see to the horizon based on your location. Reporting live, I'm Chief Meteorologist Tom Coombs.
So let's check that out. Here on the website, scroll down, and he's got this link right here. How far away is the horizon? If you click on that, it takes you to this page right here from Discover magazine, I guess. How far away is the horizon from Bad Astronomy? That's properly labeled, I think. Bad Astronomy. It could also be Bad Geometry. So they've got this picture right here, you know, to help you figure out the Earth's curvature. You got your little man here, in this case standing perpendicular to the ground, but he's looking down. He's not looking straight out, he's looking down. They always depict it that way. In fact, if we go to this other one here, Earth Curve Calculator, a lot of people like to use this one. This is the way it looks today. But I'm going to tell you that's not the way it has always looked. They've got the H0 or the observer here and the target perpendicular with the ground. But this is a recent change to the website. This is the way they used to depict it. They used to have H0 and H1 straight up and down, instead of perpendicular with the green line representing the globe. Here's a meme I created back on January 16th, and I posted it on Facebook. You see the problem here? Look at this graphic. Look at the way they have H0 and H1. See the angles? See the problem? That would mean that the person on H1 and the target are leaning inward, which means they're not standing perpendicular to the ground. They're leaning inward. I posted this meme on Facebook, and as I was making this video and getting ready to use this example right here, guess what? Okay, I posted this January 16th, and here it is February 2nd, and I go to this website and it's changed. So just to prove that they did this, you know, somebody must have showed them the meme or saw something that, you know, either myself or somebody else was pointing out to mock this graphic. So they changed it. And here's the proof. You go back to the Wayback Machine, go back to October of last year, and what do you know? There's the original one that was just, you know, a few months ago that they changed, because they know that we're on to their game here. They know that what they're putting out is crap, but at least they're consistent. They're doing the same thing everybody else is doing. So let's go back to this other one from Metabunk. Now I'm going to enlarge this graphic and orient it so that PJ is standing straight up and down again, and lower him so that he's within the observer square. Now this is what they're saying. This is the observer looking toward the horizon. But unlike their example here, where they're forcing the observer to look downward toward the horizon, my observer is in their little square looking straight out. And from the feet of my observer, the ground is curving downward, just like it would do in real life if we're standing on a ball. For those of you who are interested in doing so, here's a simple test, and it doesn't require that you be a Freemason, a Luciferian, a Nazi, an occultist, or an atheist. You don't even need to have a college education or a lot of money. What you need to do is get a long pole that would facilitate putting something up to your eye level, In this case, I've got like a 4x4 with a plank of wood on top of it. Make sure the vertical post is vertically level, and make sure the horizontal plate on top of it is also level. And then go get some paper towels. Use the paper towel tube. You can even keep the paper towels on it if you want to. But if you have just an empty paper towel tube, you can set on, tape to the top of it, and then stand behind it such that your eyeball's looking right through it. And then just look straight ahead through this forced experiment right here that keeps everything looking straight. And I would suggest you do this at a beach somewhere, so you don't have to deal with the topography of the land. You're going to know that there aren't any peaks and valleys, mountains and canyons or whatever on the ocean. You're going to have a straight, flat horizon. And if you do this, you're going to see the horizon is going to be right there. It's going to be right as you're looking through that tiny little field of view through that paper towel tube. You're going to see the horizon is going to be at eye level. And yet we've just shown you that that is physically impossible. That cannot happen. The ground has to be dropping away from you, receding downward in every direction from the point at which you're standing. That's the way it works on a ball. That's the way the ball earth math works. According to Pythagoras and according to the spherical model invented by Eratosthenes, who calculated our circumference to within about 5% of its currently accepted circumference of 25,000 miles by looking at the sun in a well and the shadow of a phallic symbol. So as you can see, this produces an extremely interesting problem for the ballers. And frankly, it means that Pythagoras and Eratosthenes just handed a trump card to the flat earthers. And pardon the pun, but there's simply no way around this problem. Indeed, if the squares of a chessboard are 1 mile across, all it takes is 3 moves for any flat earther to quickly put a ball earther into checkmate. Thanks so much for watching. I hope you enjoyed this video presentation. If you did, please subscribe to my YouTube channel, like the video, and share it on your favorite social media sites.